Good morning, my dear kids. In today's class, in the chapter electromagnetic induction, we are going to discuss the some revised numericals. Means what all we have studied, no, some motional EMF or ID current, or you can say induced electric field. So I will discuss some numericals related to that one. So almost, I think, almost all the basic ideas already we have covered it. So it's the last day. So we'll try to focus few more some numericals which may help us to learn few more better ideas of the electromagnetic induction. That one. Read the question. I'll discuss in the end. AC generator. You can read a metallic ring connected to a rod oscillate free like a pendulum. Now a magnetic field is applied in horizontal axis to the pendulum now swings through the field, then pendulum will be. We know this is problem related to eddy current. Can you remember this? So it is going to oscillate and as it is entering there will be like retarding torque. There will be retarding torque. Then similarly when it is leaving also there will be retarding torque. Like that every time when it the disk enters the magnetic field there will be retarding torque. What is the reason for that? There will be eddy current. I think I'll give some small. This is a thing. At two of the positions I'll show it if when the disk is no when the disk is entering the we'll keep in this position. So will there be any eddy currents? Yes, definitely there will be an eddy current. So here B bar is into the plane everywhere. In this region there will be an eddy current. And it is living, so in this region there will be eddy current. So what about direction of eddy current? Here again negative flux increases d phi by dt, negative EMF induced positive. The direction of eddy current should be anti-clockwise. So altogether there will be retarding torque. Similarly here there will be retarding torque. It will have a velocity v1, velocity v2. There will be retarding torque. So definitely what you can expect with this help of this. I'm not showing direction of induced current altogether. This F1 F2 are due to what? Why do this F1 F2? Retarding force produced due to eddy current. So F1 F2 are F1 and F2 are retarding force acting on the disk due to eddy current. So what do we expect now? Every time when the disk enters the magnetic field, it is going to experience eddy current. It will not experience any eddy current when it is fully inside the disk, fully inside the magnetic field. The disk. Let me write all the things. Will not experience retarding force when it is fully inside the when it lies fully inside the magnetic field region. Only when it is leaving or entering the magnetic field, eddy currents will act. So definitely, what do you expect? The speed V2 will be less than V1. You can see that. Again, when it enters, again, so like that, the continuously the speed of this will decrease, and finally it come to rest. Keep oscillating with a smaller time period. Time period is independent of these things. Hope everyone knows. Okay, this one. Read the question. If you see this, this will be loop of radius r naught. This everywhere. This the loop. I'll bring it. So finally, you can see that at any time t, this will be the situation of r. So everywhere here b bar is into the plane. Okay, get into the diagram. First is asking EMF induced, then all other parameters. First we'll go for the how to calculate that EMF induced. How to calculate the radius? I think it's purely based on mathematics. You can check it. It is the ends are pulled with a velocity v. These ends are pulled with a velocity v. I want expression for radius. So this is the thing. Suppose say this end moves a distance x. This end also will move a distance x. Suppose say this end, because in time t, this end will move by distance vt. This end also will move by distance vt. How much the length got decreased? 2 vt. 2 vt. Overall length remains same, no? Overall the length is, but the perimeter, how much it has decreased here, no? The perimeter has decreased by 2 vt. Then with that, can we calculate the radius? Logically, I think it's more mathematics, nothing to do with my physics here, no? This has moved by distance v, no? So here vt and vt. So 2 vt it has decreased here. So r naught minus, so perimeter length. Earlier it was 2 pi r naught. Now how much it is like? 2 pi r. I'll stick on to basics rather than something with mathematics. Now let's do it. Initial radius is 2 pi r naught. Final radius is 2 pi r minus 2 vt. So we have to get expression for the r as a function of this one. So 2 get cancelled. So pi r naught equal to pi r minus vt. R equal to r naught. Yeah, plus it is. Yeah, I'll make changes. R naught minus vt by pi. Yeah, I made changes. Getting now? So simple length. So now what is the flux linking the loop? B into pi r square. B is a constant. Pi, this will be r naught minus vt by pi whole square. Differentiating this is equal to b pi 2 r naught minus vt by pi into v by pi. Anyway, E equal to minus d phi by dt. So it will be 2bv. These are very important and very popular also. You check it once. Resistance per unit length is lambda, is asking expression for current. So what to do now? Expression for current will be I equal to E by R. E is 2bv. Vt by pi. What is the resistance? Lambda into 2 pi r. R is the radius at any time t. So what is R? R equal to R naught minus Vt. What all will get cancelled? 2 will get cancelled. So Bv by pi lambda. Anything direction of induced current? Can we go for direction of induced current? The direction of induced current. Negative flux. Flux is negative. Negative flux decreases d phi by dt. Positive. EMF induced negative. The induced current has to be clockwise. So please do expect questions of this kind. You check the advanced paper, they have asked some tricky questions of this one. You have to be ready for some sort of logical thinking here. There is a square loop. The magnetic field region is there. This will be much easy for me. The dimensions of this should be side length should be, Okay, no. So this is the loop. I'm going to move it along the diagonal. Okay, please read question. Please read question. It will be okay. No, we have to check like how the magnetic field, how the induced EMF will be varying. Let's have a diagram like this. Now with this, I'll come into picture. First, you start thinking. It is moved with a constant speed v. This much of information, velocity along the diagonal. Then is asking what will be the EMF induced versus the distance measured along the diagonal. So we have the information. This much of information is there. Okay, this will, let's say that somewhere in some position, it is going to enter into magnetic field, no? And after some time, maybe it is fully inside. Then it is here. Then again it will come to this position. And finally it emerges out. Option A and C are ruled out because for this time you can see here there won't be any EMF induced, no, from here to this position. So how come you can say? So what is the magnetic field, the net field? What about EMF induced in this for this particular interval of time? The loop will take some time to move from one position to other position. So for this interval of time there won't be EMF induced. So definitely I am very sure that, because the flux linking the loop remains constant, these things. So here there should be time gap. Yes, there is no time gap is there. Okay, these two. So these two are totally ruled out. Now between option B and D I should pick up. I'll put tick mark for both. Let's see that which one is correct. Now you can see this. What is effective? I think shall we go for effective length here? So as the loop gets into magnetic field, this effective length keeps on increases, no? Effective length keeps on increases here. This effective length. But sir, here there is no magnetic field. I think we should go for only this effective, or at least you can say the area will keep on increase here, no? This effective area will keep on increase. So EMF induced must increase, and finally it will attain this particular situation. Then afterwards it remains constant. Then you can see this. Again the effective area start decreasing. The very next moment finally it will emerge out. The effective area decreases. So we know EMF induced equal to B into dA by dt. Area decreases. What will be the effective rate of change of effective area? Because EMF induced is flux is what? BA. Flux is what? BA. So EMF induced is d phi by dt. B into dA by t. Now we have to check it. dA by dt, is it constant or variable? I think the mathematics, you know so much of geometry, everything. Yeah, no answer. No, nobody is able to analyze this. It's a pure maths based. This will be x, no? You call this is x. Then what is flux equal to? Flux equal to B into x square. Sri Vignesh, option D. Yeah, Vinayak Nitesh, dA dt increases and then decreases. Okay, better Nitesh, you work out there, no? Think on it. I didn't get, still I wanted response, because these are the things where you are supposed to analyze here, no? Rather than something. dA by dt will be constant. dA by dt will be constant. So how do you can say dA by dt? The rate at which area increasing constant. Area increases, but the rate of change of area will be constant. Rate of change of area or rate of the rate at which area increases or decreases, that will be constant. It's a very simple. Shall I don't want to bring mathematics. You resolve this velocity here. You resolve this component of velocity. You resolve this component of velocity. That's all you know. The rate of change of area is what? Will be constant. Component of velocity, you write it v by root 2. V cos 45, V cos 45. So what is x is equal to? The rate at which x increases will remain constant. dx by dt is constant here. So here we'll do one thing. B into what is area? Area at x square. No? So dt of x square. B into this will become 2x dx by dt. 2b dx by dt into x. What is dx by dt? Component of velocity. So that dx by dt, this will be constant. But x increases, no? There. X increases, then decreases. So therefore, it has to be this one. You have to be very careful questions of these kind. I'm making things clear. So you can't expect help from teacher. We can't teach all the things which will appear in exam. To a certain level is what we can take you. After that, a student has to analyze on his own. Why the why they are negative and positive? Flux negative flux increases dphi by dt negative, EMF induced positive. Okay, if you take that one, then it will invert because your negative flux decreases dphi by dt positive, EMF induced negative. So therefore these two should be opposite. Similarly, I brought one more. Let me magnify it. These questions are very popular in the JEE Advance. That's why I wanted to remind you. Even in eddy, even in the ring also, in that small conducting region, eddy currents will flow. That's all. No question of any second thought. Okay, read this question. There is no magnetic field in this region. There is a magnetic field in this region. It is rotating. So what is the effective? So it will be like a flux is equal to B into A cos omega t or cos theta. B as it is constant, so this will be pi, radius is r square by 2, only semicircular loop, no, it is into cos omega t. I'll differentiate this, b pi r omega by 2 sin omega t. But you look at this, t equals 0. After t by 4, the plane of the loop will become perpendicular to the magnetic field. Or no, the b bar, it's perpendicular that one. After some time, the b bar will be tangential to the plane of loop. Then it will not link for another half cycle, no. This is ruled out. First, for 0 to t by 4, the flux linking the loop will be 0, will be non-zero. I'll put it. So this will become b pi theta, definitely in terms of theta what you can write in terms of theta will be pi by 2 to 0. Afterwards the flux linking will become 0 for what interval of time? Okay, these things I'll take it out as it is rotating with uniform angular velocity. So definitely with this I can and moreover how do it will vary? The EMF induced will vary sinusoidally. So therefore here there won't be EMF. Flux itself is 0, so no question of rate of change of flux here. Then again the direction of EMF induced will change. You can see it. No, instead of this, if it is a full loop, AC generator will discuss now only. What is the AC generator? So it contains the there is some motor is set up to this, and this motor will see that it will rotate with an angular velocity omega. Then I have a bar magnets. North pole, and this is south pole. This bar magnets will produce an uniform magnetic field. And there is a loop of n turns. I'm showing only one single turn. So what is the flux linking it? Flux linking it will be equal to number of turns into this will be area into B into cos theta, as I'm going to rotate both this axis. So omega equal to theta by t, theta equal to omega t. So this will become NAB cos omega t. Differentiating this equal to minus NAB. What is N? N is number of turns. I am unable to show that. If you want, I have to draw a coil. It's not like a loop. Coil of n turns, better you call. Agree this? So coil of n turns. So this should become equal to minus NAB. So this will be NAB omega sine omega t equal to minus d phi by dt. So this will become NAB omega sine omega t. This EMF induced in the loop. So this will go for E naught sine omega t. So how this particular signal generated? The signal generated will be an called as alternating current signal. E naught minus E naught. This is T by 4, T by 2, 3T by 4. Sine wave in trigonometry, what you study? This is called like alternating. So why it is alternating? That you look at the cycles here. Positive and negative off cycles. So like this, why it is called as alternating current generator? So if this particular loop is having a resistance R, if I bring one resistance R, then the expression for I equal to E by R, or this will become E naught R sine omega t, or this will become I naught sine omega t. So this, look at the current. Current is going to alternate. Where do that current will flow in this loop only. An EMF will generate. This is what we are going to generate an AC signal. What we are using today. What all LCT is there? No, because of this alternating current signal. So what is this you have to call? Alternating current signal. In general, we just call it as an AC. It will alternate. The positive off cycle, you see that will alternate. The off cycle, positive and negative off cycles will alternate for every off interval of time. This particular EMF E naught, this is very important, depends on what? Depends upon number of turns of coil, how strong the magnetic field produced by the bar magnets, then also the area of cross section of loop. I can't increase area. It's very big problem to rotate a very giant loops. So therefore I'll go for increasing the magnetic field. Then omega. Omega also we have certain limit. So usually what is omega? So if you look at the signal frequency, AC signals are generated with a frequency 50 Hz. Can you bring omega now? 2 pi into 50. 100 pi radians per second. Convert into revolutions. So with this much of speed, the loop must be rotated. It's a strict condition. If you go for the American, European countries, they go for this as 60 Hz. In India, all the Asian countries know we are going for 50 Hz. That's standard like. This is called like a AC generator. Of course, we have another thing like a how do sir this motor will rotate, a connection will be made. That's not part of our, we need to bother much here. Why it is called as alternating? Because the positive off cycle will alternate for every off interval. When do positive off cycle will come? For every off interval, positive off cycle will come into existence. I don't think so any objective question anywhere can be asked, because already this is there in EMI. Just we are giving some exclusive diagram and we are discussing this one. This coming chapter, alternating current signals, there we will discuss again the same diagram. Okay, this is some motor which will rotate. So what this motor, it rotates the loop. It will see that the loop will rotate here. Now tell me, like, without this class 11, class 12, physics, chemistry, maths, if you don't analyze, if you don't think, how it is possible for you to understand the engineering applications? When you don't know angular velocity, when you know torque, when you don't know these things, when you are not aware of anything, just memorize question answer. Okay, got into engineering college, then their completed degree. So how it is possible for you to develop the engineering technology here? Not possible. No, there is a main reason in India why we are not producing a thinking engineers, because only few selected students are coming for the JEE Advanced or JEE Mains. JEE Advanced. The remaining rest all, what will happen, they prefer to go for theoretical discussion, question answer type. Even JEE Mains also, not depth of numerical, no. Everything is, most of things are formula based. So definitely students without this advanced level thinking, if they go for BTech, definitely their basics are not strong. So without these basics very poor, engineering applications you can never understand. It's over. You will end up with only degree without knowledge. There's a major thing that is happening. So now in this section also now, if you are not thinking, it's as good as like there's no career. For namesake, okay, you're doing BTech or something, but it's of no use. The best opportunity for you is think on them. You want to become engineer, all these things you are supposed to analyze. Otherwise, there is no career for you. Forget about future. I'm just saying that the engineering career is of no use. Means though you'll become engineer, but nothing called like a knowledge in that. Only a certificate will be there. This is happening to what? Lakhs of students every year. I think there are around some 25 lakh engineers are produced by India, this country, or even in Pakistan, Bangladesh, African countries. What is the reason there? The reason for that is like students are coming out without anything, just with a certificate they are ending up. So there the real problem arises. 25 lakh thinking brains is a very big number. Huh? But what we are doing, just without anything, just question answer, they know it. Hardly they know anything about the designs, everything. What is the root cause for this? The root cause is like starting from high school, 8th, 9th, 10th, 11th, 12th. They should analyze things, they should work out problems, they should think. So until these things are changed, not possible. This is my view. Let's take the questions. A conducting light string, okay, this is the string, is wound on the rim of a conducting ring of radius r and mass m. Resistance of this is 0 is telling. Free end of string is connected to ceiling. A vertical large it is wound like this. The terminal velocity attained by the center of ring is. Problem related to rotation mechanics. You have to go to the rotation mechanics idea. Okay, it's a ring, no? I'm bringing disk. Read workout. Meanwhile, I'll set the diagram. Everywhere magnetic field is present, and there's also a conducting plane. Okay, there's overall the structure is of this kind. Okay, we have a resistance. Yeah. Flux linking the terminal velocity attained by it. What are the various forces acting? I think we should be aware of all the forces acting. The B bar is present here. Okay, there's overall condition. No, start analyzing. What type of motion it will describe? The string should get unwound, no? As it slides, it should get unwound. So what do you expect the ring? How do it will move? Yes, it will have the first mg will act here. The string will become taut. So then this tension the string will set up a torque. It will have rotation, and also because mg will be greater than t, it will have the velocity, linear motion. The terminal velocity attained by the center of the ring. Only that is the question that is being asked here. But first of all, is it a motion EMF problem? Because the flux linking the ring is constant. The flux linking the ring is constant. Because the flux linking the ring is constant, so no EMF induced. Is it okay? No, there's this region, the magnetic field is varying. No, the flux area will vary. Yeah, this is very important. Already we discussed some numerical. Here, this area is varying. This is constant. So you write it clearly. The instruction. This area increases with the time. There's a fixed vertical plane. What shall I do after this? The ring will have both rotational as well as translative motion. Due to rotational motion, will there be any EMF induced? That's the primary question. Due to rotative motion, will will there be any EMF induced? Nothing. There won't be any EMF induced here. Only due to translative motion. So I'll write the instruction here. Due to the ring will describe both rotative and translative motion. Now EMF induced due to rotative motion should be 0. Only due to translative motion it is going to have that one. So he is asking now finally to get the terminal velocity attained by the ring. So will there be any flow of current, anything we can say here? I think this entire falling ring we can go for the circuit. B bar into the plane velocity. So this end will be Y2 cells, EMF is equal to BV, radius of the ring. Where is the radius of the ring given? Small r. So how much of current, the total current here will be flowing here? This will be B bar. Okay, current has to be like this. I, this is I, this will be 2I. Then the BIL force here, BI to R, BI to R. So then who will balance mg? The mg is balanced by 4 BIR. What is I is equal to? E by R.
So it is 2 into BVR. So EMF.
BV into 2R, no? Okay, okay. Then 2I into, if I write loop equation, 2I equal to, or 2I into R, let me write clearly here, 2I is equal to 2I into R equal to E. To IR into equal to, so therefore I equal to E by 2R. E is how much? BV 2R. Okay, this will become I is equal to BV R by R into R. 4B square R square V by capital R. Is asking to get the terminal velocity. So this will be equal to mgr by 4b square r square. no EMF will be induced due to rotatory motion. Okay, make observation. I'll go for the next one. I think this circuit is very important. We must have this background. This is very important. Read it. Read the question. I'll come into the picture after. Okay, this one. Again, I have to explain. Okay, when we switch on the cell, a current I1 will flow. This I1 is given by initially like a E by R. Then the minimum force what will require to move the rod will be this I1 will become E by R. A current will flow. Then the force required to move the rod means I should overcome the friction as well as this ampere force BI1L. And the friction is given by mu mg. So mu mg equal to, so substituting value of I1 E by R L. So what is I is equal to? Okay, now there is a minimum force. There is the first part. Second part of problem. Find the power delivered by this force when the rod moves with a steady speed. Okay, I'm going to move with a constant speed. Then what power the action agent should deliver? What power the action agent should deliver here? So for that, what is F naught? Okay, this F naught, we'll write it here. Okay, what is that? F naught should be equal to BIL plus frictional force. I should overcome these two, ampere force and frictional force. Frictional force is between the rod and the rail here. It will act at both the ends, at both the ends of the rod. I'm showing it only at one point here. So what is I is equal to now? The moving rod will behave like a cell and it's having a resistance R. Then the resultant current I is equal to capital E plus E naught by R. So what is E naught? BLV naught by R. Okay, substitute this I here. Then we'll solve it. So what is that minimum force? It is twice of that one. Okay, now we'll solve this. 2 times of mu mg plus BELR is equal to BLER B square L square V naught R plus mu mg. Mu mg plus BELR will cancel out and will be left over with B square L square V naught by R. So the terminal velocity is given by mu mg R B square L square plus ER. R also will not be there, no? E by BL. So multiply the power by action agent should be F naught into V naught. So what is F naught? F naught is 2 times of that one. Already we have this. Then multiplying with this we'll get the required value. I think better to substitute value, no? So rather than it become as very lengthy. So this much of actional power the action agent has to deliver in this given situation. I'll move to the next problem. Make observation. Okay, this is that rod. Very simple idea based one I picked. Okay, when you project this rod, flux linking it. There's the initial situation. This initial situation. Here is what we are projecting with a velocity v naught. What will happen to the rod P and Q? That's what is you mean to say. So let's get into the motional EMF concept and we'll see the flux linking conditions all. So after some time, so I do expect this rod P somewhere here. It will have velocity v. Flux linking it remains constant or varies. I think the area is varying here, no? So the negative flux is negative. Negative flux increases. d phi by dt negative. EMF induced positive. EMF induced positive means the induced current should flow anti-clockwise. Pen and paper must be there when you are solving questions, anything, analyzing. No, pen, paper, and every question something. Okay, it will happen. This next afterwards, what will happen after draw the diagram? Nothing wrong. Maybe you are unable to solve more number of numericals, but I'm telling this one, it is going to. You are going to become one of the best thinker, best engineer. See how your teacher is doing for everything is microscopically it's explaining, no, drawing diagram, then what will happen, this is what you have to learn. So that's why I never give target like you should solve 100 problem, 200 problem. It's not about, we are not bothered your number, we are bothered about your learning. Learning aspect should be there first, then comes next the improving skills, other thing. What do you expect this BIL force? Don't get scared. What will be that? Let's try first. What all we know concepts, we'll start applying them. Okay, here B bar current. Okay, here force is like this. Let me see here the force here. B bar. Constant speed V. I'm going to move this with a constant speed. Then the BIL force will act on the rod Q. No? This force will make it to accelerate. And because of acceleration after some time, so definitely it will start moving. So shall we say it will get attracted towards P. Sir, what actually, can you describe again what will happen? What actually happens here? Let there be a resistance for both the rods. Let's assume I'm moving this with a constant speed. Agreed. Then this BIL force which is acting will keep on increase its velocity. At one instant, velocity of this rod will become equal to this. Agreed. Then once velocity of this rod, velocity of rod Q becomes equal to velocity of P, then flux linking the region between the rods here remains constant, then EMF induced will be 0. Net EMF induced will be 0. For further analysis. The time in which the amplitude becomes A naught by E. This is A naught. The slider attached to the slider, this is by an amount A naught and released. Okay, I'll display this A naught and released. What are the forces that will be acting? Spring force, then as it starts moving, BIL force. A little bit of SHM idea. Here. Every time I have to draw a diagram. Yes, I'll get into. There's a rod. Now there's a spring. It is it is being displaced. There's a equilibrium position. I'm showing displaced position. So then the spring force will act here. Then flux linking, negative flux decreases. d phi by dt positive, EMF induced negative. How induced current in fact will flow in this direction. A conducting slider of resistance R, so it is sliding. So which end will be positive? Can we show this by any cell, anything like a cell? B bar and velocity, so this end will be positive. So here I'll bring a resistance and also a cell. Then how BIL force will act? B bar and current, so BIL force will act in this direction. Spring force will act here, so let this be acceleration. I think that this is what happening here. So it will have some velocity V also. I have to indicate many things. Then what is the equations of motion? Ma is equal to kx minus BIL. This m d square x by dt square kx. B, what is I? I should be equal to E by R, BLV by R. Let's see what we can do. Where we'll land up first. What all we know mass. Okay, with that we'll manage. D square x by dt square equal to kx. This will be b square L square dx by dt. Anything? No. I think some minimum common sense SHM. What is there in that? If you displace like this, spring force will act towards that. Spring will be compressed here. Spring is elongated. We can do this problem for elongation or compression. B square L square R dx by dt minus kx equals 0. See, somewhere you have seen this equation. Somewhere. I want from students answer somewhere. Somewhere you have seen this equation. Really, I landed up in some very odd equation. Now, what is this? Like, what to do after this? No answer from you. Tell me, like, which chapter? Somewhere in a chapter you have come across of situation of this kind. Damping effect, damped oscillations. So you compare with the damped oscillations. This everything. Compare with the damped oscillation. So this will become m dx square by dt minus okay b dx by dt minus kx equals 0. Damping effect, what is the b? B is called as a damping effect. So then if that is the case, then what is the expression for a equal to a naught e to power of minus bt by 2m. In place of b, what we have, therefore b is equal to b square l square r. Now calculate the time. Is bringing damping effect and EMI, induced EMF. Spring is pushed the air gradually, I'll elongate, then if I release, when I release, then it starts moving, then we have to discuss this problem. Oh.
Yes, sir. Yes, sir.
Huh?
Yes, sir.
MA equal to I don't know what happened, everyone. If I release it, will it move towards right or towards left? The rod will move towards left or towards right when I release. Spring force first will act, no, the rod is released from rest. Spring force, as it starts moving, then flux linking it changes, then EMF induced, then induced current, then BIL will come. How come you can write MA equal to BIL minus KX? Of course, this particular restoring force will act opposite to displacement. There is the only condition here. Agree this. So now you work out. So time after which A will become A naught by E. So I think I can get into now A naught by E equal to A naught. A naught get cancelled. So 1 by E equal to, so BT by 2M equal to 1. Time equal to 2M by B. Substitute solve, you will get this answer. Problems can be anywhere, linking of this. So what, the friction was playing role in the mechanical system, no, the resistance will play almost the similar role here. So therefore the resistance, electrical resistance is called like a damping effect. It will bring a damping effect in the electrical system, the resistor. Okay, we'll speed up this. We have half an hour. We'll try to wind up another 5 problems we have. Now, read the question. A square loop PQRS, it is kept nearby a long wire. This is a long wire. We have a square loop PQRS. I'm going to rotate it by 180 degrees about an axis. This axis. The total amount of charge which will pass through any point of the loop during the rotation. It is rotated by 180 degrees is telling. So first I'll directly enter into the concept like this. We know I equal T by R. What is I? dq by dt. EMF induced d phi by dt. So dq equal to de by R. d phi by R. So change in flux, so final minus initial. We write like this. So the amount of charge flown how to calculate? It's very simple. Just calculate the change in flux by the resistance. Will give the charge flow. What charge has flown through the loop. How to calculate the flux? I think we'll take a small elemental area. Then at a distance x dx. I think everyone knows how to calculate this. So d phi is equal to b into dA mu naught I 2 pi x. dA will be a into dx. First we'll calculate flux, then we'll see this. So this will become a to 2a mu naught IA 2 pi log 2. No, I'm not going to displace this loop. I'm going to only rotate the loop. If the B bar and N cap is initially in same direction, after rotating it, B bar and N cap will become in opposite direction. So if initial flux is equal to phi, what do we expect final flux? Minus phi or plus phi? If initially B bar is into the plane, look at here, B bar is here into the plane. So how is the N cap? Let's assume that N cap is into the plane. So what is initial flux? Will be positive. After rotating it, N cap direction you should not change. It should be retained fixed here. Now N cap will become opposite to B bar. So what is the flux now? Final flux will become in fact negative. If initial flux is positive, the final flux will be negative. If final flux is positive, initial flux will be negative. So therefore this dq should be equal to minus phi we have directly that value. Charge flown should be equal to only magnitude I'm interested. So mu naught I a by pi r log 2. I think will be very important for objective questions. What is use of this? Okay, let's keep it aside. But exam point of view, we start thinking something very big. Let's find out the expression for induced current as I rotate. Then I equal to dq by dt. Then we integrate. Of course, you can do it, but very lengthy it is. This approach will be much easier. So whenever a flux changes, flux changing a loop, if you are able to calculate and if the loop is having resistance, you can predict the amount of charge flown through the loop. I think that's one very simplest idea. Please do remember, charge flown through the loop. The long parallel is a distance L apart having resistance per unit length lambda. These rails are having resistance per unit length lambda, joined at one end by resistance R, A perfectly conducting rod M is free to slide. A variable force F is applied to the rod such that as rod moves, a constant current I flows through R. The current flowing will be constant. Is asking to get the velocity of the rod as a function of distance x, v of x and f of x. First we'll go for the induced current. The magnet field is into the plane. This will also have resistance, no? Rx, I'll write it. R of x. So this will have a, here I should replace with a cell. EMF, and the induced current will flow in fact anti-clockwise. I think this by this time everyone is aware of all these conditions. So for this I should apply an external force. Let's get into first what is the I is equal to E by R plus 2Rx. To lambda x. Then the acceleration of this, it is moves a constant current I flows through R. That current I is a constant is telling. Okay, let's write the equation. F external. I'm directly writing because we have done so many numericals. Only the resistance of rails has come into picture. That's all. There's only condition here. So F external minus BL first expression for velocity of the rod. Okay, here only. Velocity of the rod. Okay, this V will become current I is constant, a constant current I is will be given for us, so therefore this will become R to lambda x I by BLB. V dV by dx. You know expression for V. Differentiate this with respect to x. Substitute everything. You'll get expression for force. So dV by dx, how much it will be? It will become 2 lambda I by BL. Again you have to substitute V also, solve it, you'll get the required answer. I'm just leaving it here. Let's not bother. If the rails are having some resistance, okay, let it be. That will get added up to the circuit here. There's the only idea. Rest all mathematics, I feel. Rest all mathematics. Now again substitute the value of V here, then solve it. We'll get the required expression. Okay, anyway, I'm almost near, no? I'll do that also. Okay, this we have to further simplify it. Solve it for x.
Sir,
Yeah.
sir, acceleration we have to take dv by dt, no, sir. Okay, sir, got it,
Kinematics.
sir. You wrote v
Kinematics.
dv by dt, sir.
Kinematics over, I
I mean,
think.
you wrote
Yeah.
v dv by dx, right?
V dv by dx I wrote it.
Yes, sir.
Look, I'll do
I
one.
missed that v, sir.
Yeah. Nothing. I'll highlight it. Okay. Yeah, it will flash now.
Thank you.
Yeah. So I think now maybe a little bit, but when you come to the revision, no, analyze all the things. Like when you are studying itself, if there is a friction, what will happen? If there is a resistance, what conditions will come? Like these two rods, they'll have also capacitance. Can you remember capacitor chapter? If this having a capacitance, what? One capacitor you are going to bring it here. Like that, a student has to analyze so many things. So if this this was the revision. Revision means again not like doing new problems, analyzing it. And any problem comes, you have to analyze, not just mere solving the problem. See, we do have students who will really analyze and come to the exam. They do get better rank. There is only difference between why some students do hard work will not get suitable rank, why some students will get a very good rank. It all depends upon the way they analyze things. See, everyone is putting now, anybody is interested to get a rank, definitely they'll do 10, 12 hours or 8 hours work. Minimum 8 hours everyone will do work. Read the question. Make habit of reading question. Once you read question, I think you feel you can do something. So moving rod, it is moving with a terminal velocity. So some information is there. This having a resistance. This having a resistance. So then magnetic field B bar velocity. So this the moving rod will behave like a cell. Then B bar here also. The induced current will flow in this direction. here I1, here I2. Sir, how come you are giving direction? Flux in the upper loop, negative. d phi 1 by dt, negative. EMF induced, positive. So anti-clockwise. Flux in the lower loop, negative. d phi by d2 is positive. EMF induced, negative, clockwise. Okay, got it now. So don't get scared. Number of loops are there. Let it be here. Then BL force definitely should act up, and there is a mg. This much of information what we have, and the rod, this rod, particular rod is moving with a constant speed. This is a B. I'll indicate all the things. And this is that rod. This is a rod, in fact. Find the terminal velocity of the bar L and the value of R1, R2. Is asking the terminal velocity, this Vt, I'll call it, and the resistance R1, R2. We have power dissipated here. First, I'll take help of this. BIL, capital L is telling. Okay, yeah. BIL equal to mg. Because moving with a constant speed, no, we are discussing this problem. So what all we know BL mg. I'm getting expression for current. M 0.2 into 10, B is 0.6. Length of the rod is 1 meter. 2 by 0.6. Or 10 by 3 ampere. This is the expression for current. Okay, fine. Okay, now we got this current. After this, what to do? Power dissipated is there. Power dissipated. P1 should be equal to E square by R1. P2 should be equal to E square by R2. We know R1, we don't know R1, we don't know R2, we don't know also E, but we know P1, P2. I think this equation is not at all helping, no? Here, more troublesome. Nothing wrong, okay, write it. But is asking to get R1. We know P1, P2. We don't know E. What is E? E is in fact BLV. We don't know V, but both E and V are unknown. Yeah, what shall I do? We know everything. I'm sure. We know Motional EMF. We know Faraday's law. We know Lenz's law. We know current density. We know KVL. We know KCL. We have to think here. That's all. It's not that how much you know. Okay, what all you know. Okay, now start analyzing it. What is the known thing? What is the unknown thing? How to bring that? I think this is something very essential. We know most of the things now. It's not that we don't know anything. We are very good in almost all aspects, but still you see somewhere we are struggling. I told you this is what you have to analyze. You have to make observation how to get the unknown things with all the known things. What all we know P1, P2, and we know I. We want the E.
Sir, I equals to I1 plus I2.
Yeah, fine. What is I1 again?
Then or E equals to I into R1 R2 by R1 plus R2. We can
But we
use
don't
this
know
power
R1 R2.
equations and solve for E, sir.
Okay, you mean to say I equal to E by R1 R2 by R1 plus R2. I don't know E, I don't know R1, I don't know R2.
Sir, I got E as 0.588. I solved it, sir.
Okay, that one. Now I'll do one thing. I'll go for the overall power. P should be equal to P1 plus P2. What is that? Total power. Total power should be equal to E into I. Total power is E into I. Do we know E? We know I. I'll come to this. The total power should be equal to E into I. This is P1 plus P2. E is what? We don't know. P1 plus P2 we know it. So what is E? BLV. P1 I'll write it 0.76 1.2 is BLV into I. Do we know I? Yes, it is. Substituting this 1.96, B is 0.6, length 1, terminal velocity we don't know, V. Do we know I? 10 by 3. With this I'll get V. Once you get V, then you'll get E. Then once you know E, then you'll get R1, R2. Anybody? Terminal velocity? Gunitra? P1 plus P2.
0.98.
0.98. Now you can get the EMF induced. Then you'll get R1, R2. I think this is the some important part of the problem, this idea. It's not that we don't know anything. We know. We have to search a condition here. I think this happens in many problems of physics. Even if you check the advanced, no. So like this, around 30% numericals are there where you know everything, but this didn't strike you. Value R1, R2. Gunitra? R1, R2. Gunitra, value R1, R2. If you can tell, we'll end up the class.
Sir, R1 is 0.455.
0.455. R2.
0.288.
0.28. 285,
288, sir.
288. Okay, do think on different types of numericals are there. So some math based, some diagram based. So many things will come. They're very versatile and linked with so many other systems, with capacitor, with friction, with gravity, rotational motion, torque. One, I think, is some sort of like a revision of so many ideas are there. No. So definitely, any best creative questions can also be asked in advance or mid. So prepare for all the different types of numericals, analyze it, how the conditions will come. Okay, I'll end up the class. Okay, kids, like we had a discussion of some around 11 numericals is what we discussed about the applications of motional EMF. I think this is a endless topic. I can just keep on carry on solving different types of numericals here. So I suggest you like at least some 50 numericals motional EMF or around 40 different types of, with friction, with spring force, with normal contact, with gravitational potential G, with capacitor. Next further will come with inductor, then rotational torque. So all these are several ideas with spring force are there. So under action of all this, how do that motion EMF system will survive or will do come into picture. So such numericals, if you pick, analyze, think on it, you'll get a broad aspect. I think these are the topics which you should pick up for revision, I feel. When you're going for revision in the final exam, when you're doing revision, pick up topics which are multiple ideas are there, like SHM, rotation mechanics, this particular EMI chapter, especially motional EMF, motional rotational EMF, then electromagnetism, F equal to BIL. I think so, and F equal to QE bar in the electrostatics. So if you revise that topic, you are almost revising some 10-15 chapters at a stretch. So you must give priority for revising such topics again and again, so clarity will come. These are some threshold at the end of the syllabus. When we approach the advanced exams or mains exam, I do insist like what topics if you revise, a lot of benefit will be there. Okay, after I'll end up the class. Thank you all of you.